Hey, I'm Chris and I'm working in the research department of XITASO. I've spent the last 1.5 years researching in the field of post-quantum cryptography. We are facing a major cryptographic challenge. In the near future, efficient quantum computers could be able to break parts of our current cryptography that protects our digital communication. This is why we have to change our systems to utilize new encryption methods that are considered secure against quantum computers, also known as post-quantum cryptography. The problem with this is that we still have very little knowledge about how such a migration can be implemented in practice. Therefore, we conducted a systematic literature review to create an overview of the migration phases, real-life applications, as well as the biggest challenges that still stands in our way. Our systematic literature review was based on the PRISMA 2020 statement as well as on the guidelines by Kitchenham et al., which led us to divide our entire methodological approach into 3 phases: planning, conducting, and documenting. Within the planning phase, we developed a research protocol which ensured quality as well as a systematic approach throughout the entire process. It also includes our research questions. One of them is, for example, what are the identified steps to migrate software systems towards PQC? Within the conducting phase, we systematically searched for relevant literature. Initially, we identified 3,000 articles and reduced them to 21 articles, which then built our final paper set. In the documentation phase, we summarized our key results and provided a replication package so that our whole procedure can be reproduced. Our 3 key results are the identification of 4 migration phases, the applications of post-quantum cryptography, and the challenges encountered during migration. Let's take a closer look at the 4 migration phases of software systems, which are the diagnosis, planning, execution, and maintenance. The diagnosis is the first phase in which the information about the technical assets and their cryptography is collected and assessed. In the planning phase, the assets and their cryptography get further prioritized, considering the previously collected information. This leads to the creation of a migration plan, which is then used for implementation in the execution phase. Finally, the maintenance is an ongoing phase that almost begins together with the execution phase. It is motivated by the fact that the infrastructure considered will change over time, thus the data needs to be adapted. Within our systematic literature review, we've identified 4 key implications. One of them was the lack of an established migration framework. Based on the literature, the identified migration steps as well as roles, which are required for a successful PQC migration, are neither uniformly defined nor widely recognized. Furthermore, real-world migration projects carried out so far are very sparse. In our work, we proposed a general PQC migration framework. In addition to the migration phases, we've also defined the corresponding roles to get one step closer to the actual practical implementation. However, to create a truly reliable framework, comprehensive real-world migration projects are needed to validate as well as refine our concept. We hope our contribution will support future research as well as real-world implementations of the transition towards PQC.